Oxidation-reduction reactions. Oxidation-reduction reactions are also called redox reactions. They're chemical processes in which the oxidation numbers of an element are changed within the reaction. Oxidation occurs whenever the oxidation number increases from a loss of electrons. Reduction occurs whenever the oxidation number decreases from a gain of electrons. So oxidation-reduction reactions keep track of the electrons in a reaction. In a redox reaction, elements within the compounds involved gain or lose electrons. Oxidation is when the element loses electrons and goes up in oxidation number. Reduction is when the element gains electrons and go down in oxidation number. So in this example here, we can see that zinc plus oxygen yields zinc oxide. When we assign oxidation numbers to this, we can see, according to the rules, elements have an oxidation number of 0. So this would be 0, and this would be 0. But now on the other side, O has a -2 oxidation number. And if we want to calculate zinc, zinc plus oxygen has to equal 0. So if oxygen is -2, zinc has to be +2. So we have just assigned oxidation numbers to oxygen and zinc. Now, zinc is going from 0 up to +2. Zinc is becoming oxidized. It has lost electrons, so it's oxidized, and it's going up in oxidation number. When we go from 0 down to -2, we have oxygen has been reduced. It went down in oxidation number, so it has been reduced. Oxidation and reduction are coupled, and that allows us to keep track of the electrons within a reaction. We can write the half reactions indicating where the electrons are going, but sometimes writing half reactions like this gets confusing. So I like to just keep track of the oxidation numbers within the actual reaction. So here's another example. Elemental sodium is 0 oxidation number. Elemental chlorine is 0 oxidation number. But then over here, chlorine is a group 7A, so it's a -1 oxidation number, and sodium is a group 1A, so it's a +1 oxidation number. So sodium went from 0 up to +1. It lost electrons, it became oxidized. Chlorine went from 0 down to a -1. It gained electrons, it was reduced. The problem with the thought process here is that electrons have a negative charge. When you gain negativity, when you gain electrons, you become more negative because you're gaining that negativity. So it's kind of a reverse way of thinking, but keep it in track in your mind. Oxidized up in oxidation number because we're becoming lighter, we're giving up that negativity. Reduced goes down in oxidation number. We're gaining that negativity, we're gaining electrons. So an oxidation-reduction reaction is an electron transfer reaction. Oxidation is the complete or partial loss of electrons, so you're giving up electrons. While reduction, you're becoming more reduced because you are gaining those negatively charged particles. So it's a complete or partial gain of electrons. The oxidizing agent is the substance that is reduced. It gains electrons, making it possible for something to lose them. The reducing agent is the substance that's oxidized. It loses electrons, making it possible for something to gain them. So there are a couple different things that we can remember this by. Oil rig, so oxidation is loss, reduction is gain. Or Leo the lion goes grr. Lose electrons, oxidation. gain electrons reduction. Those are just two mnemonics to help you remember. I prefer the lion one because I'm an animal person, but you can choose which one to help you remember. The oxidizing agent, again, is the substance that causes an increase in the oxidation state of another substance because it gains electrons. It is reduced in the process. The reducing agent is the substance that causes a decrease in the oxidation state of another substance by losing electrons. It is oxidized in the process. So, Leo, Ger, lose electrons, oxidation, gain electrons, reduction. So sample exam questions, you will be given a reaction. And one of the questions could be, is this a redox reaction? Well, in that instance, you'd have to calculate the oxidation numbers of each component of that reaction and determine if they changed. If they stayed the same, it's no. If they did change, it's yes. What's oxidized? Well, the element that increases its oxidation number is oxidized. What's reduced? The element that decreases its oxidation number is reduced. What is the reducing agent? It's the substance that was oxidized. What is the oxidizing agent? It's the substance that was reduced. So how to answer these questions? Again, you start by writing the oxidation numbers of each element in the chemical equation or each component. And then if the oxidation number of any element changes, then it is a redox reaction. If it's a redox reaction, the element that gained electrons was reduced and the element that lost electrons was oxidized. The oxidizing agent was the element that was reduced and the reducing agent was the element that was oxidized. So those are written out steps for people that like to see visual steps. I'm going to go through several examples now. So, in the reaction between zinc and hydrochloric acid, we end up with zinc chloride and hydrogen gas. So if we assign oxidation numbers here, zinc is 0 because it's elemental. Hydrogen is +1 when bonded to nonmetals. And chlorine is a -1 because it's a group 7A. We go over here, -1 because it's a group 7A, and now we have to calculate zinc. We have 1 zinc, which is X, plus we have 2 chlorine, which we just determined to be -1, and we set that equal to 0. X minus 2 equals 0. Move the 2 over, X is +2. So zinc is +2 here, and hydrogen over here is 0. So is this redox? Well, zinc was 0 here, and now it's +2, so yes. It changed oxidation numbers. It is a redox reaction. What was oxidized? Well, the zinc went up in oxidation number. It was oxidized. What was reduced? Well, the chlorine didn't change. It's -1 here and it's -1 here. So the chlorine is not going to be oxidized or reduced. But if we look at the hydrogen, it went from +1 down to 0. So hydrogen was reduced. Zinc allowed for the reduction of hydrogen. Zinc is our reducing agent. Hydrogen allowed for the oxidation of zinc. Hydrogen is our oxidizing agent. So when you are watching this video, what I just stated answered those key questions that you're going to see on the exam. So I recommend going back through this example and listening to those words a couple more times and listening to that answer a couple more times. Take down notes on those answers and study that, because that's going to help you answer the questions in the future. Okay, so looking at this one, which reactant was the reducing agent in the reaction between zinc and hydrochloric acid? Well, as mentioned here, zinc went from 0 up to +2. So zinc is oxidized. Hydrogen went from +1 down to 0. Hydrogen was reduced. Because zinc was oxidized, it allowed for the reduction of hydrogen. Our reducing agent is actually zinc. Which reactant is reduced in the following equation? So here we assign oxidation numbers. Elemental calcium is 0, elemental oxygen is 0, and now we have to calculate what this is. Oxygen is -2, and because this is -2 and this is a group 2A, this is +2. -2 plus 2 gives us 0. So calcium goes from 0 to +2. Calcium was oxidized. It lost electrons, it was oxidized. Oxygen went from 0 to -2. Oxygen is the one that was reduced. So go ahead and pause the video. I would like you to assign oxidation numbers to everything. Keep track of all of these and determine whether it's redox or not, what was oxidized, what was reduced, the reducing agent, and the oxidizing agent. Okay, so for this first one, elemental hydrogen is 0, elemental fluorine is 0. Fluorine is always -1, and the rule says hydrogen is +1, which makes sense because +1 minus 1 equals 0. Hydrogen went from 0 up to +1, so it did change, so this is a yes. Because it went up, the H2 is our oxidized element. F went from 0 down to -1. F is our reduced element. The oxidizing agent allows for the reduction of the opposite substance. So the oxidized element is the reducing agent, and the reduced element is the oxidizing agent. The agent allows for something to happen. So fluorine allowed for the oxidation of hydrogen, while hydrogen allowed for the reduction of fluorine. Next one. So elemental is easiest to assign first. We start out with bromine. Bromine is -1 because it's a group 7A. And magnesium is a group 2A, so this is a +2. So magnesium went from +2 down to 0. So yes, this is redox. Because magnesium went down, magnesium was reduced. Bromine went from -1 up to 0. Because bromine increased its oxidation number, Br is oxidized. The oxidizing agent is magnesium, and the reducing agent is bromine. So now we go here. To make things simple, if the family stays together on both sides of the equation, you can simply assign the oxidation number of the entire family instead of figuring out each individual one. So the oxidation number of sulfate is -2 because that's equal to the charge of that family. And that's one of the rules for assigning oxidation numbers. So we have sulfate sticking together on both sides of the equation. We can go -2 for both of those. For potassium, we have to calculate it. So if this half is -2, we have 2 potassium, which we're going to leave as X, plus we have 1 sulfate, which is -2, and we're going to set that equal to 0. So now we have 2x minus 2 equals 0. 2x equals 2 divided by 2 on both sides. We get +1 for potassium. Now over here, we can see that this component here is hydroxide, and we're going to give it the charge of that polyatomic ion. So this part is -1. Now because hydroxide is -1 here, potassium is a group 1A, we can give that a +1. Here, barium is a group 2A, this is a +2. We can also calculate it like I showed up here, but we can just assign it based on the rules. And then barium again is a group 2A, so that gives a +2. So now we're going to determine if any of these have changed oxidation number. Potassium went from +1 to +1. Sulfate, -2 to -2. Barium, +2 to +2. Hydroxide, -1 to -1. This is not a redox reaction, so none of these apply. All right, and here is another round of examples. So I'd like you to pause the video, go through these, and then we will talk about them together. Okay, so we have elemental hydrogen, which is given a 0. And then we have rules for oxygen and hydrogen. Oxygen is -2, hydrogen is +1. Is this redox? Well, hydrogen went from 0 up to a +1. Yes, it's redox. So what was oxidized? Hydrogen. What was reduced? Oxygen. So hydrogen went from 0 up to a +1. It was oxidized. Oxygen went from a 0 down to a -2. Oxygen was reduced. Next one. According to the rules, elemental is assigned 0. Monoatomic ions are given its charge. And let me not write it that way. We're going to put +2 because it's an oxidation number. So iron +2. So when we go from this side to this side, iron went up to +2. Iron was oxidized. Zinc went from +2 down to 0. Zinc was reduced. When we look at the next one, elemental is given 0. And when we have monoatomic ions, it's given the charge. So the charge is +2 and +3 for this one. Aluminum went from 0 up to a +3. So aluminum was oxidized. Iron went from +2 down to a 0. Iron was reduced. Here we are going to calculate or put in the oxidation numbers. So elemental copper is 0, elemental silver is 0. Our polyatomic ions stayed together on both sides, so we can give it the charge of the polyatomic ion, and then we don't have to worry about calculating that nitrogen. This has to sum to 0, so if this is -1, this has to be +1. And this has to sum to 0, but there's 2 of them. So we have 1 copper plus we have 2 of those -1 nitrate groups, and we sum that to 0. X minus 2 equals 0, so X is actually a +2. So to calculate copper, it's +2. And now we're going to see if this is redox. Copper went from 0 up to +2. So yes, it is redox, and copper happens to be what was oxidized because it went up in oxidation number. Silver went from +1 down to 0, so it was reduced. The nitrate family didn't change, so it was not oxidized, was not reduced, did not participate in redox. So copper was oxidized, silver was reduced. One of the ways that I think about this visually is oxidized to me sounds like oxygen, and when you're coming up for a breath of air, like if you're swimming and you come to the surface and you finally break the surface of the water and you get a breath of air, you're coming up for air. So if it increases in oxidation number, just think about reaching up out of the water and coming up for a breath of air. If it goes up in oxidation number, it is losing electrons because it's becoming more positive and it's getting oxidized. If it's going down in oxidation number, it's getting reduced. And it's going down because it's gaining those electrons. So go ahead and work through some of the practice problems and homework problems, and let me know if you have questions.